Kubernetes, and though we have been not following the book, but eventually we would converge with the book as we finish all the prerequisites. So we covered basis of machine learnings. We saw how to set up Jupyter notebook on Kubernetes. We tried some command with Jupyter notebooks as well, and then last time we understood how we can containerize kind of a machine learning model and deploy it with Docker. So we saw one small demo last time. Um, but today we're going to continue with the second demo, which our colleague Francis is going to kind of share that another demo of how to containerize a model and so forth, along with a model on classification, I believe. And then, if time permits, we'll take a look into the ML flow. At least look at some of the basic stuff there. Yeah. Okay. So I think with that, Francisco, you can go ahead and share your screen and take it forward.
Perfect. Thank you. So, hello everyone. So I'm going to share my screen. I have a kind of short presentation in order to define the outline, the things that we are going to see today. The first point is just basically an introduction of the business case, where I'm going to talk about a little bit about the model that we are going to package and ship in a container. Sorry, it's just. Then basically, what we are going to do is to explore in the data using something that we have already covered in previous session. It was done by Nipandra, in terms that we are going to explore the data using Jupyter notebooks. In this case, what I'm going to do is what has been done before, is to use a Jupyter hub in order that is in a Kubernetes cluster, because at the end, what we are going to do is to deploy the model that we have already built in a container locally, but as well in Kubernetes. So I think it's very worth it to start using a Kubernetes cluster, and then at the end of the presentation to see how to deploy locally in order that test out whatever we want to use, or even run the model locally and then in a cluster. So let's move on. So the first thing is basically the business case that we are going to cover today. This is something that has been introduced before, which is a repository with some examples of machine learning. And the business case here is to try to predict the RDC using logistic regression. I try to condense a kind of definition of what is a logistic regression without going further in details, and ended up in a kind of discussion if we might agree or not, depending on our background. But basically, I asked to ChatGPT in order to give me something very short and straightforward. And logistic regression is a statistical method which classifies things in a binary way. It could be 1, 0, or it could be whatever you want. And as far as I'm aware, logistic regression, all the features that you need to use are numbers, basically. And even so far I remember, when I was involved in terms of machine learning, most of the features that you are going to use, even those that are categorical, that are test or label, normally you ended up converting in a numerical way. So in this case, we will see an example how one of the features is categorical or is a label, is converting a number. So basically, this model, what it's doing is just to compute the probability to figure out if the feature that we are trying to predict is 1, 0, or whatever classification we have already defined for that. So after going further, in order to start to work and explore the data, I would like to introduce as well, which is the project machine learning life cycle, which is something that is described in the book. So basically, the stage that is covered in the book related to a project machine learning is something that we as well covered in previous. Basically, what I'm trying is to recap in order to make a point what we are going to cover today. So basically, we are going to codify the problem as well as we understand that should be solve the problem. Then we are going to ingest the data in a way that we define. We are going to run some feature engineering intent to decide which features are needed for solve the business case. And I like that step because it's something that we are doing exploring. We are not going to do it formally, but we are going to do it during the explore. And even the model, the example that I got, somehow is not well documented, but somehow they decide, okay, we are going to take these features in order to predict the category. Then basically what we are going to do is to build a model, somehow validate it, deploy, and then monitoring. So today, basically, what we are going to cover is this stage. So the first one is exploring the data, building, somehow validate it, and there I hope, if I don't miss it out the point, I hope to show you something that I learned in the hard way. That is how important is how you consume the features. I hope if I don't miss that point, I can show you how to something that I learned the hard way. And finally, basically, what we are going is to deploy the model locally in a container, which is something that has been done in the previous session, and in Kubernetes, which is a kind of a step further related to the previous session. So let's go to explore the data. So to explore the data, because I have 3 monitors, so bear with me. So okay, I have it here. So as you can see, this is a private IP. Basically, what I have done is
We
something.
cannot see your screen. Reshare the
Oh,
screen.
okay, sorry. It's maybe because yeah, thanks for that. It's because maybe, okay, I share the window rather than the screen. Sorry. Yeah, I got it. Now you can see it. Yeah, I'm sharing exactly the screen. So everything that I need something, I will move to this screen. So I was sharing the window. So okay, basically, as you can see here, I have a private IP. I've been following something that was done that is well documented. That's by Nipendra. So let me, is this article that we have here? Okay, is this, yeah, here is it. Okay, let's move on this to this one. Bear with me. Okay, so here is well documented. It's something that is already written by Nipendra in terms that how to deploy Jupyter Hub in a Kubernetes cluster. So the thing that I do further is just to prepare something that the business case that we are going to study today, that is this one, that is from the example repository that we are taking most of the model in order to how to containerize and then to deploy. So basically what I have done is a kind of tiny version of this in order that we can run, and even how I prepared it to run it in a Kubernetes cluster. So basically what I have done is to prepare here is to have a kind of all the Python libraries that I needed, so that I have my first line is install all the libraries that I needed, so we can do at the same time. So that what it's going is to prepare my environment to run the rest of the notebook. Well, this is just pure text, and then now start the party, we can say it that way. So basically, what I'm importing is the panel library in order to explore the head of the data. That at certain point I can do it manually here in using a notebook, using the Jupyter notebook. But here sometimes it's very worth it to explore the data in this way. Then here is the thing that I mentioned before. So the first step that we are going to do to preparing the data is just to change one of the column that is categorical, is how is defined in the repository. It's just this column that basically is the absent. It's a pure text, it's a label, and is converted to a number. But before moving further, let's recap what is the data of the model. So basically, what we're trying here is to predict the possible RDC for a person based on these features. So basically, it's the systolic blood pressure, which is something related to the heart, how much tobacco has been consumed, other features like low density lipoprotein cholesterol, if we have someone in the audience that can figure out or translate those, it would be nice. Otherwise, we have to assume that is a feature that maybe makes sense or not. Then we have the adiposito, which is another feature more. This is the categorical one that we converted to number, which is the family history of heart disease. It is, I assume that someone in the family has already experienced heart disease. Then we have other like obesity, alcohol, this type E that is on a kind of a score, and the age, which is very convenient from my point of view. And the final one that we're going to predict, which is the binary thing that we are going to predict, is this one: is the if someone is very likely, is some person with this feature is likely to experience a heart disease or not, based on the rest of the feature. So in a nutshell, we have like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, like 10 features. And based on these 10 features, we are going to predict the last one, which is if someone is very likely or not. It's not kind of probabilistic, it's just kind of white, black. It's very categorical, yes or not. We don't have a kind of range of that. So after reviewing that, let's move on to exploring the data and even a kind of proposal of the model running this notebook. So after doing that, we have the head of the data that we have already commented before. And now after prepare the data, just changing this column, we have that the family history is now to 1 series. Another, even we can we can do the opposite. It's a kind of proposal to figure out if there has been someone in the family that has already experienced a heart disease based on the rest of the feature. But in this case, we are going for the last one column, which is this one. So after exploring here the data, we have, for instance, that this person was 52 with this obesity. Is for me is unclear if it's in kilograms or is a kind of ratio. This alcohol and this tobacco features in terms, I think it's the kilograms of tobacco that has already consumed, I guess, during the life of that person. So somehow we can see that the data, in a nutshell or in a simple view, in a naked eye, it doesn't. It looks nice. What I mean with that, it's sometimes when you are in this stage, the obvious thing that you try to find out is if there are missing data. Most of the time that I have been involved in machine learning, I spend a lot of time cleaning the road that, for whatever reason, is unknown the data for one of the features. For instance, I manage some data set that maybe the obesity for the second record of the table, we don't have it. So we need to make a decision. And there are many ways to approach that. It could be sometimes a kind of taking the average, just simple deleted the row. But this is a decision that we have to make when you are doing some features engineering, because that will be a kind of biased vision of the model that we're building. I hope that is clear. If anyone have another point of view, please feel free to jump in the middle of the conversation and provide another opinion. I'm sharing what I experienced before. In my case, what I experienced is that I manage a record set related to tickets because I was trying to figure out using another classification algorithm to try to find a kind of classification of we are going able to comply with an SLA depending on some features like the day of the week, the hour of the day, and other things, and type of SLA we have to comply, the kind of things. And I find out that unfortunately part of the record set that I was trying to clear didn't have all the information. So in this stage, once again, it's very important to make a decision in terms of what are you going to do with the missing data, because it may be conditionate the model. So let's move on. So here, basically, in the next row, what it's doing basically is just to try to select or try to to tinker or play with a little bit with the possible candidates of columns. And for doing that, basically what it's doing is a good practice that is, so far I remember, is just to try to correlate the features two by two. Just to if try to find out if there is a kind of natural correlation between two features or two variables. We will see a kind of visual example. So as a result of that is running this library in order to get a kind of matrix to try to identify if we have a kind of natural correlation, for instance, between features like could be tobacco and LDL or LDL and deposit. So as a result of that, when I run this line, I have this beautiful how we call map, where we can see something very interesting. So because basically what it's doing is just pairing the features in order to find a kind of natural correlation. We can see here with obesity and adiposity, there are some strong correlations. It's not one, which is the one that we would like to find. That is the natural one that we find when we pair the column SDP with SDP, because it's the same variable, so the correlation is one. But here we can find in this, how is called this, warm map, I think, or heat map. No, I think it's heat map. No, it's the right word. We can find some natural correlation between two pairs of variable. However, let me warn you that even you find some of them, at the end you have to make a decision.
So,
So,
Francisco,
yeah, sure.
what I'm kind of trying to see here, or understanding, is that the correlation between the uh, two variables. So you have the x variable, x axis and y axis, and if
Mm-hmm.
both of them are same, then of course it is one. That's what we see in all the diagonals, correct?
Mm-hmm.
And then with adiposity and obesity, we see 0.72, right? That is the one which you highlighted, right?
Yeah, that's correct. For instance, we can take the opposite example. So the age looks like that is not correlated with the type of A,
Hmm.
which is this
Correct.
variable.
Hmm.
But even we can take the age as a kind of moving in a horizontal way.
Hmm.
Sorry, and you can see that is not correlated with this one, and somehow is strong correlated with a deposit.
Hmm.
But if we take, for instance, the obesity, which could be something very intuitive for us, we can see that is as well very correlated with this variable, but not correlated with the type A.
So
And
then it means
even,
that, okay, so what we can read here is that if somebody has obesity, they
Mhm.
may have adiposity as well. Correct. That is what we have to read from here, right?
Yeah, exactly.
Correct.
So basically, it's a kind of there is a kind of correlation that's mean that is not a casualty. I mean, the tricky things in statistics.
Hmm.
So that two variables are correlated doesn't mean that one is the cause of the other, but at least we can figure out that maybe we can find a kind of formula or a diagram or mathematical structure that can correlate them, but it doesn't mean that there is a causality between of them. Is the tricky thing. So, for instance, if taking this and making a kind of extreme example, if we can find a way to correlate that today is raining and I lose money, maybe we can start to record all the data, and every time that it's raining I lose money for whatever reason because I spend more money or go
Hmm.
for a drink or whatever. But it doesn't mean that one explains the other. It could be many other causes, but in a mathematical way they are correlated, so it's very likely that we can find a kind of mathematical formula that can explain the behavior, but not explain the behavior, can explain a kind of how they works together, but it doesn't mean that is the cause of knowledge. Maybe the cause is just because it's raining I decided to stay home and spend my money playing
Hmm.
in on internet or whatever.
Right.
So this is an extreme example, but here normally, so far I remember the time that I was studying machine learning, it's a best practice to run this kind of test in order
Hmm.
to try to find a kind of correlation.
Right.
Why? Because at the end we have to pick a kind of because maybe we compromise the model if we take the tens variable in order to categorize this one. Maybe we can start to drop some features that we see in a natural way or in this kind of visual way that are not correlated. So why we are going to waste time
Right.
computing something that is in a kind of we don't find in the data or in the possible model that are not correlated. It's like adding noise to to this step. So this is one of the main step in my understanding, in my experience that I've been involved in this, is to make a decision which features can work. And sometimes even it could happen that maybe we don't see any any correlation between the variables, and we make a kind of biased decision to say, okay, I want
Yeah.
to explore the data because I want to find a kind of model that works with age, alcohol, obesity, and that's all. Maybe family history. So what I'm saying here is basically my experience. If one day we have a kind of data science here or a person that is more experienced in this, maybe can provide more information.
Yeah.
In my case, in the business case that I was involved, that was basically categorized ticketing. At the end, we made a kind of a strong decision to say, okay, we are going to try to predict if we comply with SLA using these features, and basically we start to work on that. So here, somehow you can see that at the end, when he's trying to create the model, just pick it 1, 2, 3, 4, 5, 6, 7, 8. From 10 variable, he dropped 2 variable away. So we have, for instance, SBP has been already dropped, and somehow makes sense because there is no strong correlation with any other features. So this is one that has been dropped. Tobacco is already here. A deposit is already family history. Tape A, obesity, alcohol. The
And the
other
last one is,
is
of course, the whether somebody has it or not, right? So of course that has to be dropped. The last state, right? Whether you have it, heart disease or not, has to
sorry,
be dropped.
pardon. Sorry.
So I'm saying that only one has been dropped, which is the SPB, and second is of course because we have to predict that last variable, right? That HPHD variable. That's why it's been dropped. Correct.
Yeah, the first one, SPP, has been
Yeah,
dropped.
correct. Only that one. Yes, correct. Yeah.
So basically, what it has done is just in Panda to select the columns,
Yep.
to apply a filter in terms of the column. So let's move on. So basically, at the end, what he's doing is to take in another column is so basically what he's going to create like it's like try to represent this in a kind of mathematical way. So the X variable, it could be the variable of the data, trying to predict the Y variable, which is basically the function that we are going to try to build with the model. So as we done in the previous session, basically what I'm going to use this library in order to split the data in a training data and then in a test data in a way that we can run the model. So this is done by this library. So basically there are other libraries that are doing that and even other frameworks that are doing that. And then at the end, after split the data in training data and test data, we are going to use the train data for the X variable and the Y variable. And we are going to train our model. So if we run this step, I couldn't figure out why I always have this error. And after that, basically what we are going to do is a kind of to find a correlation, if we can say in that way, between the X variable that we has already picked or selected with the one that we try to categorize, which is the Y. And if we run that step, we have a kind of is under 1, but is above 5. So, well, it's not bad. I think it could be very nice, this. And then this step, I introduced myself. I'm going to pick the first row of the table. If you can see, this is the first row. Yeah, no. Tobacco seal. Oh, this is a random data that I already play. I think this is a random data, but we can play with this row if we want. And then basically is to predict the data. And we can have here that based on this data here, we have a prediction, a result of 0. So here we can play with this column. For instance, we can put the first row that tobacco here is 12. Sorry.
Let's give 12 kgs, 15 kgs.
Yeah, 12. I think then LDL is 5.
That's okay. Let's run it. Let's see what happens.
Sorry?
Let's see. Let's run it. Let's see what happens. It's okay. We understand.
Yeah, sure. So we still having 0.
Okay.
Let's change another. Sorry, I only play this row. Sorry, let me. We still having 0. Okay.
Okay.
Let's change, for instance, to is a deposit is 23. So yeah, I have the real data in Python. So family history is present, so is 1. Type is, this is 49. So let's load this and try to predict, and we still haven't 0. So let's
Let's change the
change.
obesity to 48, whatever. And with the obesity only, I think.
Yeah, let's see. The obesity is 25.3. Sorry about my voice. 3, and then alcohol. I think it's the alcohol, the one. Yeah, 97. So let's change this one. I think it's the alcohol is the one. And then the H is 52, isn't it? Yeah, 52. So let's see. Okay, it's working the model. We have predicted that it's already 1. So this person is very likely to have a kind of disease, heart disease. So if we change here, for instance, this variable to 38, sorry, maybe the prediction is no.
Okay.
So we have a kind of model that works. We have already modelized here in this notebook. Having one of the things that pointed out the book is that using Jupyter Hub is a kind of shared environment that people can discuss about what are the best selection of the model. And somehow that resonated with me because I was involved in another project. My role there was a kind of consultant in terms of other platform, but I attended many meetings about how is the role of machine learning in the business case that they want to do. And something that I already lived there is that 2 data science, they were doing a great job, but they were doing in their laptop, which is something that pointed out the book, that most of the data science tend to create the models and to train the models in their laptop, which is a kind of constraint. So putting a kind of framework, a platform like Kubernetes, where people can share an environment and discuss everything, is definitely a step forward in terms to let's do a correct machine learning project. So following with the agenda, the next thing is that let's have a look. Let's explore the solution that has been developed to containerize this model. So first to doing that, let me show you that the solution is already in GitHub. I will put in the Slack channel the link of this repository. So I think it's worth it to explore the README. So basically, it's covered some of the steps that we are discussing here, and even they have some value links of things that we have already commented here. And basically, this part of here is like a kind of the scope of the solution in what is included and not included. And basically, we are going to work in those last steps. You have the requirements if you want to build yourself locally. It worked pretty well in my laptop, which is all the developers say. I hope if you find any issues or something like that, just highlight it, reach out to me, and hey, this is not working. I something that I missed out is that everything is working. I have an Ubuntu laptop, so I couldn't have a chance to test it out in my Mac, which is pretty old. So it would take a lot of time to run some of the things. And unfortunately, I don't have a Windows laptop, so I couldn't test it out anything in Windows. But somehow I'm confident that it works. I'm not sure if the make, if there is a kind of solution for Windows in terms of using make command, but for me, it's very convenient in terms that I can grab some of the things that I'm doing here, just rather than through some sort of command. We will when we explore the solution, I will show you what is wrapped up in those make file macro. So this is the solution that is here. As a result of the solution, I've built some Docker image that you can consume when you want to deploy this in Kubernetes. Because I was thinking how to do it, and basically I found worthy, and for me it was a kind of chance to explore and to tinkering a little bit with the GitHub action. So
Nice.
basically I decided to have this here working.
Pretty good. Pretty good. Yes.
So let's go for the solution. Okay, how I manage this that looks like very complex. Looks like a little bit complex. Okay. So let's explore a little bit first the folder. So this is the make file that I mentioned. This is something that was born to compile things in C++ or C. But nowadays, in all the projects that I've been involved, for me, it's very convenient to grab up some, rather than develop a sort of bunch of script in order to just to execute this step. I prefer to doing that. Is something to do something like this. It was introduced by a friend of mine, a colleague that was very experienced compiling C. And even he moved forward and he used a lot this, and all the project that he has done, I found this file very convenient
Very
and
useful. Very useful. Yeah.
very useful. And I find out there is a kind of common practice in open source to have this kind of macro. So here you have more or less all the steps that we will cover at the end. So this is a little bit further to create a kind of function, because this definition is consumed by two of the macro. So here, this project is in Python, but I'm using to package the project. I was thinking to do it in a kind of a straightforward setup tools of Pythons, which I'm not more familiar. I'm a little bit familiar with Poetry, which is a framework to package Python code that I used in my previous position. And it's very handy, just because you, as long as you have a project, you execute Poetry in it and create this beautiful Python project TOML file with all the information that you want to add it. And then if you want to package, it's very convenient. We will see later how it's built. So, well, the normal step here, I developed some tests in order to when I was building this, to test it out, things that are working. So you have a folder for test. This scripts is the one that will be executed in the Python container. So basically, this is a kind of the endpoint. So we have a script, a kind of client script to run the model in a kind of, to build the model in a kind of command line. We will explore that later. This folder should be empty. Here we have the model already created here, but if you download or you clone the repo, you would see that this already empty this, and the result when you already build the model and you package everything, you will find this. One of the outcome of building the model is to have this file here. Then we have a kind of to build the model in Python. I decided to create two classes. One class is basically to generate in the model, in terms that basically for me it's more convenient. I prefer to create class rather than create a straightforward scripts. So basically I create a class with different methods to the actions that I want to create. Basically here what I want is just to generate the model. So I have another additional method that basically is a kind of double test that the file has been already uploaded or taken by the class. So you can take this class and convert in a straightforward script. Just for me, is more convenient to have it this way, because for me is better organized the code. But people that prefer work with objects, there are people that prefer with traditional scripts and functions. And then we have the last class, which basically is, okay, I have already built the model. It's already shipped in this file. that we will discuss later, and somehow we discussed in the previous session, which basically what I'm doing is to consume this file, which is the model already built, and create a method that is predict. And what I'm passing, the argument that I'm passing to this prediction is the data that I want to predict. I hope I don't miss out this line, and we can run an experiment. And this is the hard lesson that I learned. That's why I have highlighted and commented, which is very convenient for this kind of a scenario. So then we have here the folder that is basically all the deployment in Kubernetes. I tried to avoid it, make complex and create a Helm chart, basically because I didn't have too much time to do it. And here we have a kind of basic base image. I mean, this image that we are going to create, it will work for the two stage of the building. One is of the building the model. One is to build the model, and the other is one to kind of deploy the model using a API. So this base image work for those. We will see later how it's working. Well, here I have how to create a documentation, how to create your, well, the example that we found out with the notebook that we see, and as well how to create, we put here, how to create a cluster, a Kubernetes cluster based on kind, with all the links that is needed, and how even to install the Jupyter Hub. Here we have the data folder, and here we have the Git actions. So
Wow,
this
is amazing. Actually, you've done a perfect job.
this one for testing is already disabled in the repo because it's creating a lot of noise, and I need to find a solution for that. What I'm using is the release process. Release process is very manual, and my ambition is try to automate in a way, especially based on some experience that I have, and I have seen the way that is automated the release, and I want to I pretend to imitate what I have lived, but I will add some flavor from my side. So basically, this action is already executed and create a Docker image when you push a tag with a specific format. Is when it's triggered that. This one is a kind of pretensions of to try to trigger the action to build a Docker image for testing, but creates a lot of noise. So that's why it's disabled in the repo. I have the code here. I didn't delete it because my vision is as long as I have a spare time, try to work on that and try to find a way to automate it. So I think it's time to open a console and start to work on everything. So let's explore how works the solution. So basically here I have two things that is, well, I think I'm going to make this bigger. So I think everything looks fine as far as I'm aware. So here I have a Kubernetes Kubernetes cluster. Sorry. So this is the one that I already created, but we are not working on that. What we are going to build the model locally and even to consume locally. Okay, for doing that, I'm going to create a new tab here. I'm still in the repo. I'm going to make this a little bit bigger. And I will start to use all the make macro that already mentioned before. Basically, what I'm going to do is to follow all the instruction that you have here in the README file. So the first thing that I'm going to do is just I missed out the build. Really? Okay. Okay. No, here is it. So the first thing that we need to do is to build the image. So here there is a macro that I need to document that is this one, make clean. We are going to clean our environment. Basically, what we are doing here is if we have already built the image that is called in this way, we have already deleted, and even we have already deleted this folder. So if I do something like model is empty. If we want to see in a graphical way, we can see here that is already empty. Okay. So far. So now let's build the image, which is I forgot. Oh, build image. Okay. So what it's doing is basically is to package the Python code using poetry, which is this line here. And then what it's doing is to start to build the Docker image. And as you can see, if we move here to the code, to the Docker image, where is it? Here. You can see that basically what it's doing is this one is run pipe install with the package that we already provide. So basically in the previous stage with Poetry, what we has done is to create this distribution folder. Then we move to the temporary file inside of the Docker, and then running this line that is pip install in the temporary folder, the distribution package that we have in Python is all the things that we are seeing here. After finish that stage, we start with the regular things in Docker. Basically, we're transferring all the data. Here we have the summary. This is all the stage that we have done in building the image. We can check it out doing something like Docker image ls. We can see that the image is already here. Okay, it's 30 seconds ago, and it's a big image. But it's a big image just because the Python image that I already downloaded, someone was curious about the size of the Python image, is 1 gigabyte. Maybe one of the convenient things about Python is that if you want to create the base Python image are really, really huge. So maybe you need to go for something very customized Python image, or maybe other language. I don't know. That's I leave that on the table. So sorry. So after doing that, so let's clean this. The next step is if we go here once again to what we are going to run is the model. The outcome of the model is just to provide this. Of this macro is to provide the output of this step is to provide this file. But let's see inside what we have. Basically, what we are doing here when we run the step run the model, run generate model, we are calling to this run image definition. And we are ended up in this part of the else of the tree of the if decision that basically is Docker run with a specific name, map the data folder or directory, and then map the model and as well the script, because basically at the end what we are doing is to execute this script, the client script that I already mentioned. That if we go here to see the script. Basically, the script, what it's doing is to something so simple. Well, they have some parse arguments because you can run even from the command line if you want. But basically here, what we are doing is just create an object based on the of the class that we have already defined. We have a result, and well, the result is basically that the class basically do everything. The outcome of the executing the class is the file indeed. Basically, I asked to return the name of the file that has been already created with this method. So basically, sorry, I said wrong. So we instantiate the class, we create this object, and then we use the object to call this method. And the outcome of the method is two outcomes: is to create the file and give you the name of the file. That's why you can see here. So let's go to run that step, which is make run gen. So we can see that basically is running this command, and now we should have this file in this directory. So it's model. We have the file already here. Okay. So this is something that we already succeeded in the previous session. So let's go for the next step, that is to have an endpoint to consume the model. So for doing that, we are going to do this step because I'm going to deploy locally. The local deployment is to run this step, which is run the model API. So let's clean the, and we have it. And if we want to test it out, I have already some macro as well for test it out. So let's split the screen. No, sorry. So make test The first thing that I'm going to test it out is a kind of connectivity. I created to the endpoint a kind of URL or route that is ping, we can see here. So if we go into this script, we have two routes. One is the prediction and the other is a kind of ping. So the first thing that I'm going to do is just to ping the endpoint. And here, just because I make it a kind of with parameters as well in order to be, this is very special for my deployment because I have other things in the background running. So the most likely that you experience in your laptop will be this, not this one. So my IP for this endpoint is this two. So here we are. We have that we have already run a cool command, and we have pong and the name of the host name, which will be very convenient if we have time to explore how it's deployed in a Kubernetes cluster. So, okay, we have already succeeded here, but we can test with real data. Once again, and port. And we have, we can see that has been in the log that we are seeing, in the icon of the log, we can see that we have already called the prediction method. And we can see that we are injecting this data, calling to this endpoint, and the result is something that I did this in order to make easy to understand what's going on. So we have the host name, which is the host name of the container that we are running the solution. This is the previous data that we have already sent in order that everything is transparent and clear. We are not doing any sort of magic here. And then we have the result that is 0. And this is, okay, this is using the data, the made up data that I have in the previous. I'm not using but we can change it. We can even create this and modify and use other data. And we ended up doing that.
That's
So
fine.
let's go.
That's fine.
Sorry?
Yeah. We can move to the next step. We can skip that data change, right? Yeah.
So okay, let's open another, and let's move on to the folder Kubernetes. So here, if I run some Kubernetes get all, okay, already I have already deployed the model. So I think I'm going to clean out a little bit this, delete, deploy ML, kubectl, delete service. So get all, we might see everything is terminating. Okay, and let me clean meanwhile, delete PV data. No, I don't remember the name. It's incredible. PV. So, okay, kubectl, delete PV data. Okay. Oh, maybe I messed it up because I should delete the claim first. No. Let's try in parallel. kubectl, delete PVC data. Okay, we have both. So if I do something like something like this, like kubectl get PVC all, kubectl get PVC all. Somehow we have everything cleaned. The only thing that we have here is just the persistent volume that is already created for the Jupyter Hub. So let's deploy the Kubernetes things. So the first thing that I would like to warn you to do that is when you follow this instruction, you need to be aware of the relative path of the data folder. So this is this script is already thought to execute from inside of this folder because you have to go one level up and then go to the data. So after running this script, the first thing that you need to check it out. You have all the things. You have everything here in. Thing is here. Yeah, here is how to. Yeah, in this document, is already documented all the steps that you need to follow to deploy things inside of the cluster. So okay, so the first thing is the first step is to check it out that your Kubernetes cluster, get nodes, has the data directory already mounted. Is the right thing. So let's do something like Docker's IT MLOps work bash. Yeah. So if we go here, we have the data already inside of the cluster. So good so far. The next step is let's create the persistent volume and the persistent volume claim. So you have here the YAML file to do that. Is kubectl apply f data, and if we do kubectl get pvc, we should see that we have already bound the PVC data with the persistent volume that we have already created. So the next step is up to you. You can deploy first the deployment or the service. So basically, I may need to change. This is the deployment and this is the service. So okay, it's documented here in this file. Okay, I will show you. Yeah. So all the steps are already here. So if I open this in preview, you have all the steps here, okay? Maybe after this, I will fix it out some typos and maybe this one like readme, and I will make clear that this is the document to deploy in a Kubernetes cluster. So let's move on. So I'm going to deploy the deployment. kubectl apply fsml. So if I monitor this get all, I can see that it's already creating. Now it's going to be deployed very fast because I have already running the deployment here and everything is catched out. If you do, if we create the cluster from the scratch, it would take no more than 3 minutes. It's depend of the capacity of your computer. But basically, we have here one pod. Because at the end we can play a little bit in a scale how works everything, and this is a step that you never need to miss it out. Is that the service is a load balancer, so you need a load balancer. So here in my laptop, I'm using the kind load balancer that is this one. So this is yeah, but I need to run. I think I already have running here. Okay, I have already running here. Okay, so this step is very important because otherwise you will see the load balancer pending, the service load balancer pending for IP, and you need to have this. I went for the kind cluster just because it's very convenient, but if you're using Minikube, it's already shipped there, so no problem about this step. So let's go to deploy the service. kubectl apply f kubectl get this. So now we have our service already here. So let's test it out again. So we use now we need to move to the root of the repository and run again our test. So let's run first the ping, IP, and yes, it's a typo.
Comma, yeah.
And here we are. We have the response spawn and the name of the container, which is this one here. I found this convenient because if we scale, we can monitor where is executed the model. So now let's test it out with real data. So make a test once again with IP. Well, I'm a little bit lazy today. And then port. And here we are. We have the model shipped or deployed in a Kubernetes cluster, doing like this. So now we go for doing something very Kubernetes thing, that is scale the deployment, and let's see how it works. Service replicas. Let's go for 2. Everything will work very fast just because it's already cached. So kubectl. Okay, let's, and we might have one in it. Okay, we have in one worker and another work. So let's go for the ping. We have the response for this one. Let's execute again. And here we have the response for the other. So basically, it's a kind of round robin, what is playing underneath the load balancer. So now let's test using the proper API. So we have this node that is already responding with the same data. We run again, and we have the other node, the other pod that is responding with the model. Well, and that's pretty much. I think we have already covered all the points.
Yes.
We have already shipped the model inside of a container, and then we put it inside of a Kubernetes cluster. So, any question, anything that you want to discuss?
This is pretty good and perfect, I believe, Francisco. I think the approach you have taken to put the make files, put it the test cases, put it all the steps, documentation is pretty amazing. I'm pretty sure that's going to be useful for many folks. Uh,
I hope so.
so yes, I think this is perfect. What I could say at this point of time. Thanks again for your all the efforts what you have put up here. So I
Oh,
believe we are going to use it a lot. Yes.
for me, it has been a pleasure. I feel like, okay, you have a, a real business case to do something. So
Yeah, it is.
thanks so much for the opportunity to present this a kind of homework that I have already done.
Yeah, this is like a homework, but I think it's worth doing. I believe, and somebody who's doing it from scratch and doing it, I think this makes sense. This kind of builds the confidence, right? They okay, now give me a problem, I'll try to solve it, right? So of course, we data science may require some more efforts, but I think this by doing as a kind of as a part ops, part dev, part whatever SRE, this is perfect, right? Like if we don't know this kind of thing, this is just amazing.
Perfect.
Yeah. So now I
It's
thought
a
of
it's a production level homework, yeah.
yeah, correct.
So yeah, I mean, really,
Yeah, sure
really
thing.
need. Yeah.
We can
Just
move to
curious,
production.
Francisco. Yeah, yeah, it's always there. Room is always there, right? So I was just curious, like, how much time did you have to spend on this? Like, if
Unfortunately, too much time. But it was a pleasure. It was like feel young again.
Yeah, but I
that's good.
believe from next time, maybe if you get some consulting work, this would be piece of cake, right? Because already things are set up, you know how to do it. So I believe I think it's going to be helpful for all of us, not just you. I believe all of us are going to take benefit what you have done, and then that's for the community. It's for right. Great. So I think the next step was to kind of explore ML flow, which we'll do it next time. But just to kind of highlight the problems, like today we just saw how we can containerize a model and we can put in a container and then put in a Kubernetes cluster. But now think about currently we have not seen how to uh, change the parameters of the models. So there are the different hyper parameters. There are some other configurations like yeah, even the splitting of test data and other stuff, right? So if you split the test data, if you change some parameters, how things are going to look like, or how do you going to make sure that okay, if I am a data scientist and I have want to try with five different parameters, right? Now or 10 of them, right? Now once I've done my test, I want to pick up the best one, right? And nobody's going to kind of sit down manually and doing this thing for you, that okay, you take a model, you run even for git pipeline also, right? But currently we don't have a documentation of it, right? That okay, which hyper parameters are being used for which particular configuration, right? So how do you kind of try to achieve that? So I maybe just quickly share my screen, and then
Okay.
of course we'll do it in the next time. But let me first get it, if I can. 1 minute. Where is my other screen? Yeah, here. Something is wrong actually. Just give me a sec. Okay, let me share my screen. Yeah. Hope you can see my screen here. So what I've been experimenting with this ML flow, and with the ML flow, we could basically I'll just show you quickly. I'll not take much of a time. There are different 4 or 5 different runs I have, right? And these runs have different configurations to kind of like these are the parameters alpha and L1 ratio. Again, I'm not too familiar with all of the insights of that, but there are the parameters are there, and based on that, I can kind of figure out some data out of it. What is the like? I don't know. It looks too fancy right now, but all of these parameters make some difference when you kind of build and run these models. And of course, by just deploying on a container, we cannot keep tracking to kind of um, in a way we cannot keep deploying the models and then see how it's performing and so on, right? We need something to happen beforehand, like evaluation, right? If I'm changing this parameter, how does it affect my performance of my model, right? And that is what this ML flow is all about. It is kind of going to give us that particular series of things. Let me quickly get the documentation here. Uh, yeah, so of course, see, as we all know, right, these steps are required to do any kind of work in the ML space, right? Data cleaning, I think we talked about all of these things, right? But we need to have some kind of documentation of it. If I want to change the model, which model I should change, why should I change? There should be logic behind that, right? And we can do these things with ML flow. And then once in the ML flow, we can have a deployment thing also. Once the way we have building an image, we can automate this thing with ML flow. We can simply say ML flow build Docker, something like that, right? It can build, and I believe it can connect to a different endpoint as well, through which we can then deploy to any of the cluster and so on and so forth, right? SageMaker, Azure Machine Learning Service, and so on, right? So basically, this is like you can have this ML flow stuff. Then you can say build a model and then deploy it, and then you can serve. So all those things can be done. So of course, it's a lot of stuff, but of course, for our purpose, at least we'll see some demos, understand a bit, and then of course we can go back and then dig deep as we kind of continue forward. But I believe this is a right step what we are doing. So we have already done like a way to containerize the model. A logical step to kind of look at this ML flow, and once we have covered the ML flow, then we can go back to the book and look at the book's example of the machine learning stuff what they are doing it, and then we can deploy on ML flow. One thing would be remaining is I believe what is not we have covered so far is that how we are going to continuously ingest the data, which can be fed into the model continuously and do a prediction. Of course, we'll kind of explore it later, but I think things are looking very interesting right now. We got basic concepts in place, and now if you look at ML flow, it make a lot of sense for us for sure. Yeah. So I think with that, I think we are good for today. Anybody has any comments?
For me, it's perfect. Now that they introduce ML flow, I can say that can make the life easier because if you have to do all these kind of things for each project, it will be a kind of nightmare. So, well
Yeah.
introduced the ML flow point because I think all we have done today is a kind of uh, pretty easy for ML flow to use it. Yeah, thank you.
Okay. Great, guys. And see you guys next Thursday. Looking forward to the sessions. Yeah. Okay. See you guys.
Yeah.
All the
See
best.
you
Bye.
guys.
Bye. Bye,
Bye.
guys.
Thank you. Thank you.